The fifth learning objective that we want to look at is internal rate of return. This is the fifth method for evaluating major capital investments, heavily used in industry for the past 20 or so years, and will continue to be used heavily. There are some drawbacks to the IRR, however. This is the rate at which my discounted cash inflows equals my cash outflow, the discount rate, in effect, that makes the NPV of an investment zero. And again, we want to look at a hurdle from the CFO. She will say, well, all future projects of equal risk have to jump over our hurdle or our target cost of capital of, say, 15%. If your project jumps over that hurdle, we will accept it. If your project IRR goes under that hurdle, we will reject it, and you'll be an unhappy camper. And here's an example. So when you see the letters IRR, you want to write down on the piece of paper when you're doing the calculation, or type it into Excel, NPV equals 0 equals. When you see IRR, write that down. NPV equals 0 equals. Minus the first cash outflow, plus the first cash inflow over 1 plus R, plus second cash inflow over 1 plus R squared, plus third cash inflow over 1 plus R cubed, and so on. And then solve this equation for R. Again, know the mathematics first. Second, learn how to type it into your scientific calculator. Third, learn how to type it into your financial calculator. Fourth, which has all these functions built in. It has an IRR key right on it. And fifth, learn to type it into Excel in the raw mathematical format. And then fifth, type it into Excel using the Excel function at IRR and learn how to do that. It's very, very simple. And would I use all these methods in practice? Yes, I did. Whenever I was doing a $50 or $100 or $200 million project, I wanted to make sure that answer was right. So I would test it 5 different ways. I would do it mathematically. I would do it on a scientific calculator. I'd do it on a financial calculator, and I'd do it in Lotus 123 or Excel to make sure that I was getting the correct answer. All of these instruments will give you one correct answer. There may be multiple IRRs in practice, so that's one thing you want to look out for. And we'll go over the conditions under which that happens. This initial investment is 100, and it will turn back to the, let's say 100 million, and it will turn back to the CFO 60 million in year 1 and 60 million in year 2. And the question is, what is the percent internal rate of return? Does it jump over her hurdle rate of 15%? In this case, so what do I do right away? NPV equals 0 equals minus 100 plus 60 over 1 plus R plus 60 over 1 plus R squared equals 0, because we said NPV equals 0. Find the rate at which my discounted cash inflows equals my cash outflow. And we start an NPV profile. So we start guessing and checking, plugging and chugging, as my students like to say. We plug in a 0%. Is that the IRR? And the answer is no, because the NPV comes out at 20. Is 5%. So I plug in 5% in for the R and see if I get an answer of NPV equals 0. And the answer is no, I get an NPV of 11. So 5% is not the IRR. Is 10% the IRR? I plug that in and I get an NPV of 4.13 million. So the answer, no, 10%. And keep on going, 15%, 20%, and create this NPV profile. And we see that the IRR comes in at about 13.1% on this project, if those cash flows are correct. So those are estimates. Those are our best guesses. And in this case, it would not jump over the CFO's hurdle rate, so this project would get rejected. Here's another example. Project costs $435.44, and this can be $1 million. That's a cash outflow today. It brings in $100 million the first year, $200 million the second year, and $300 million the third year. The required return is 18%. What shall we do with this project? Should we accept that? So when we want to do the IRR, we write down NPV equals 0 equals minus 435.44 initial cash outflow plus 100 over 1 plus R plus 200 over 1 plus R squared plus 300 over 1 plus R cubed. Profile, NPV profile, plug in different percentages, 0%, 5%, 10%, 15%, 20% for R, and see what your NPV is. And we want the point where NPV equals 0. And in this case, the CFO has an 18% hurdle rate, and this one comes in at a IRR of 15%. So NPV is negative at 18%. We would reject this project also. How do we do an IRR calculation in Excel? Very simply, we list the cash flows, the negative cash flow first, and then the positive cash flows. And off to the side, we put enter in a function that's built into Excel, equal IRR paren B2 colon B6, and that scans all the cash flows. It iterates. It does the exact math we just went over, and it iterates back and forth, and it finds the rate at which NPV equals 0, which in this case is 27.2%. So again, Excel can be a great tool in calculating the internal rate of return very quickly. Problems can arise, though, with the IRR, so it has some detriments you want to be careful of, especially if we have non-conventional cash flows, which go minus, plus, minus. First of all, the CFO doesn't like to see this. CFO likes to see minus cash outflow today, then plus, 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 plus. If you come in with some cash flows of minus, plus, minus, she will be suspicious right away, but let's test it out and see what can happen. In this case, so again, we write NPV equals 0 equals minus the first cash outflow, minus 60, plus 155 in, plus a minus 100, and again, we discount that minus 100 by 1 plus r squared, so it's minus 60 plus 155 over 1 plus r, minus 100 over 1 plus r squared, and we find that there can be multiple rates of return with these non-conventional cash flows. When they go minus, plus, minus, these are called non-conventional cash flows. Be very wary, and the CFO is probably not going to like the picture just as soon as you step in the door. You do the NPV profile, you start plugging in 0%, 10%, 20%, and see what the NPV profile curve looks like, and you see where it passes through the x-axis at 0, where NPV equals 0, and you can see in this case there are 2 points where the NPV is 0, and that is at 25% and at 33 1/3%. So in this case we have 2 IRRs, and this can happen with multiple non-conventional cash flows where you have positive, negative, that sort of thing. So be very wary using IRR in this case. So Descartes' rule of sign tells us that you might be careful. You might have several IRRs. You might have one IRR. You might have none. So here's another example of non-conventional cash flows. You're requesting $51 million from the CFO today, and for that you'll give him back $100 million in year 1 and a negative $50 in year 2. Again, we have non-conventional cash flows. We may have 2 IRRs, we may have 1 IRR, we may have no IRRs. Be very, very careful. There could be more than 1 IRR. In this case, I do the same thing. I say NPV equals 0 equals minus 51 plus 100 over 1 plus r minus 50 over 1 plus r squared, and I solve, and there may be 1. In this case, there are none, surprisingly. So take that home and try that out. See if you can find an IRR for these non-conventional cash flows in 9.5. You're not going to find one. It's very, very it's impossible in this case, in this rare case. So Descartes' rule of sign tells us that the maximum possible number of IRRs is equal to the number of times that the cash flows change sign. So if they change sign twice, you might have 2 IRRs, you might have 1, you might have none in that rare case that we just showed. So that's problem number 1 with IRRs. Be careful with non-conventional cash flows. Problem number 2, be careful with mutually exclusive projects, where you might have a piece of property and you're going to decide to either put a new, let's say, Sonic, or you might put an apartment building. You can't do both. You can either put the Sonic on that site or an apartment building. You can't do both. If you take X, Project X, you can't take Project Y. If you take Project Y, you can't take Project X. These things are not mutually exclusive, and they are said to be independent. So which one is better, X or Y, is the question. Obviously, the best way to look is to look at the NPV. Be careful with the IRR with mutually exclusive projects. Let's say, here's an example. Both of these cost $100,000, and they have the various cash flows, which are different. Investment A pays off a little earlier, and then investment B starts slowly and pays off later. And the question is, which is a better investment? They both cost the same. The IRR in investment A is 24%. The IRR in investment B is 21%. So with an IRR decision point, we would take investment A because it jumps over the hurdle better and higher. But the question is, when you do the NPV profile and draw these curves on the XY axis, with NPV up the y-axis and rate out the x-axis, that's your NPV profile graph, you see that these two mutually exclusive projects may cross over, where you take investment B at lower rates and then investment A at higher rates. So you have to be careful. In this case, they cross over at 11.1%, and you can find that by doing a third column and take B minus A. So you take back at that in that last table, you take all the B values minus the A values and create a third column called B minus A, and then do an IRR on the third column to find the indifference point. So you can see from this chart that at low discount rates, we'll choose investment B. BBB has the higher NPV, and then it crosses over at about 11.1%. And then you can see that at higher discount rates, we'll take investment A, AAA at 15% and higher, or actually 11.1% and higher beyond that crossover point. Don't rank mutually exclusive projects based on their returns, their internal rates of return. Could be misleading. Always look at NPV when looking at mutually exclusives. Here's an example, 9.7. Two different projects. Can't do both of them. One costs $400 million, one costs $500 million, and they turn out different cash inflows to you. Which one is better? Should we take investment A or investment B? These are mutually exclusive. So again, we take columns, create a third column called B minus A. Watch the sign. So in time zero, it's 500 minus 500 minus a minus 400. So you get a negative 100 when you do B minus A. On year one, you take 320 minus 250. That's equal to 70. And in year two, you take 340 minus 280, and that's equal to 60. And again, you do an IRR on that third column. So NPV equals 0 equals minus 100 plus 70 over 1 plus R plus 60 over 1 plus R squared, and you get an internal rate of return of 20%. So this is the crossover point for those two mutually exclusive projects, and we're indifferent between the two at 20%. Again, always use IRR when you have mutually exclusive projects. Internal rate of return, very popular in practice. Used heavily with and separate from and with the NPV. Oftentimes leading to identical solutions. Very easy to communicate, but be careful when you have mutually exclusive projects, and be careful when you have non-conventional cash flows. Use NPV in that case.